Okay, so today's lesson is on rewriting without fractional exponents. So you may want to pause the video and write this down. In example 1, we have a base of x and it's raised to a fractional exponent. So we're going to rewrite this using a radical. So I use some letters here to help us remember what they stand for. So P is the numerator. P is going to represent the power. And then the denominator is going to represent the root. So now when we change this from a fractional exponent to a radical, we're going to make our radical. So you're going to make a V like that, and then go up a little higher and over. And then the R, the root, whatever that number is, goes in the V. Okay, the X becomes what's called the radicand. So whatever is inside the radical is called a radicand. And then P is the power on the X. So P would go on the X like that. Or sometimes you might see it written like this. I prefer it like this. Okay, so let's take a look at another example. Okay, so in this example we have 3x is the base, and they're both being raised to the 2/3 power. So if we want to write it as a radical, since we have grouping symbols here, the 3x is going to become the radicand. I think I spelled that wrong. So yeah, it's misspelled radicand. I'm not sure why I got the N in there. It's been a long day. Anyway, so first thing we're going to do is draw the radical. So this symbol right here is called a radical. Then we're going to put the radicand in. Okay, and then we're going to put the root in here. It's also known as the index, aka root. And then we're going to raise the 3x to the second power. So that means we're going to square both of them. So if we were going to simplify this answer, we'd square the 3 and we'd square the x. And then that would be our final answer. Okay, now let's take a look at this example. Now notice in this example we do not have the parentheses. So, which means that the 2/3 is only on the x. So when we write this one, we're going to leave the 3 on the outside of the radical. Okay, because it's 3 to the first power. The x goes inside. The index, I'm going to use index and root interchangeably so that you get the idea. The index goes in here, and then the power goes on the x. So that's how you would simplify this one. Okay, let's take a look at another example. This time we'll have a base. Let's say I'm going to make this up 2, and we'll go to the 1/2 power. And then let's say we have a to the 1/2 power. So this time, since the indexes are the same, we only need to make one radical. Both bases will go underneath. It's a square root, so remember you do not have to write a 2. That's assumed to be in there, okay? And the powers are 1, so this would be 2 to the first power, which is just 2, and a to the first power, which is just a. So that's how we would do that one. Let's take a look at another example. So let's say we have m to the 3/4 power, n to the 2/3 power. So notice this time the two indexes are different, which means we would have to make two radicals. So this first radical is going to have a root of 4, a radicand of m, and a power of 3. Then we'd need to make another radical, and this is multiplication between the two. This time the root is 3, the radicand is n, and the power is 2. And then that would be your answer for that one. Okay, this next segment is learning how to go from a radical to a fractional exponent. So we're going to be rewriting an expression without a radical. So the first thing we do is we take the radicand, in this case b, and make that the base. Then we take the exponent, and that's going to go in the numerator. And then the root, aka index number, goes in the denominator. And that's how you go from a radical to a fractional exponent. Okay, let's look at a few more examples. So, taking this example, so we're going to take the radicand, we're going to make it into the base, then the power goes in the numerator, and the index goes in the denominator. Always look at your fraction, because if you can reduce it, you should. In this case, we cannot, so that is our final answer. Okay, next one. Remember, when the index or the root is invisible, it's a 2. So this, take the base, and you're going to do each one separately. So x power over root. So x to the 3/2. Take the next radicand, becomes a base, 2 over 2. Remember to check your fractions to see if you can reduce, and this one can be reduced. So we can simplify this to x to the 3/2, y to the first power. 2 over 2 reduces to 1. And then this would be completely simplified. Next example, we have two radicands. Remember, you got to take each one separately. Or, since 5 is to the first power and m is to the first power, we could group them together. So let me just show you them separate, and then let me show them to you grouped. So 5 power root, m power root. A more efficient way of doing this, since they're both to the same power and they have the same root, is to group them together, and then the power for both of them is 1, the root for both of them is 3. These are all equivalent expressions. Okay, let's look at another example. Example 5. So remember, take each thing, each letter, each number, anything in here separately. So starting with the x, power root, 2 over 6. Y, 3 over 6. Z, 1 over 6. Then, of course, we're looking to simplify, so we're going to have x to the 1/3, y to the 1/2, and z to the 1/6. And then that would be as simplified as we could get. Okay, let's look at one more problem. We're going to extend this a little bit further. We want to simplify this expression. So how do we do that? Well, we're going to apply one of our rules that we learned. And that's this rule here where we first of all distribute the 2/3 to both of them. So we're going to have 64 to the 2/3 power. And then we have m to the 9th to the 2/3 power. Okay? And so we're going to go ahead and evaluate this. If you can't evaluate this like this in this format, you may want to put it in radical format. So let's move this to radical format. Maybe it'll make more sense. So we're going to make a radical. 64 becomes the radicand. 2 is the power. And then the 3 is the root. So now it's your choice. You can either square it first, which would give us a pretty large number, or we could cube root it first. So I would try cube rooting it first before squaring it. We want to try to make it smaller before we make it bigger. So the cube root of 64 is going to be 4. So the cube root of 64 is 4, and then we square that, and we get 16. So 64 to the 2/3 power is 16. If you're not sure how cube root works, you would just need to find a number that you multiply times itself 3 times to get 64. Since 64 is a perfect cube, 4 times 4 times 4 is 64. So the cube root of 64 is 4. And then we can square that, and we get 16. Now for the letter. Well, let's apply the rule. We're going to take 9 times 2/3. So that would be 9 over 1 times 2 over 3. 9 times 2 is 18. Let's write down the base first. 9 times 2 is 18. 1 times 3 is 3. And then we can simplify that to 16m to the 6th power. And we will be doing many more problems like this in the near future. All right. Thanks for taking the notes. I'll see you guys in class tomorrow.